So over the course of the next two lessons, you're going to learn how to take analytical data from an experiment and actually transform it in order to determine the formula for a compound. Now, in order to do that, in this lesson, we are first going to learn about empirical formulas. So an empirical formula is the simplest ratio of atoms present in a compound. And in order to be an empirical formula, that ratio has to be made up of whole numbers, okay? So we're gonna look at two different examples of how we can take analytical data and convert it into an empirical formula. So for the first one, it tells us that I have a 2.50 gram sample of compound that contains 0.90 grams of calcium and 1.60 grams of chlorine. So I actually didn't need to know the information about the 2.50 grams because all that I care about is how many grams of calcium and how many grams of chlorine I have. So I have 0.900 grams of calcium and I have 1.60 grams of chlorine. And what I'm going to do with this information, when you write a formula, so I know that my formula is going to be Ca something, Cl something. And my goal in this is to determine what those subscripts are. Well, those subscripts are simply the ratio of number of moles of calcium and the number of moles of chlorine. And so what I need to do in both of these problems is simply convert my mass into moles. So I've got grams on bottom, I've got moles up top. Same thing for chlorine. For chlorine, grams on bottom, moles up top, okay? And then what I need to do, because this is grams per mole, I need to write the molar mass of calcium and I need to write the molar mass of chlorine. So the molar mass of calcium is 40.078, so I'm going to put my molar mass on bottom because it's grams per mole. And it's that many grams for every 1 mole. For chlorine, it's 35.453 grams for every 1 mole. And so what I'm going to do to solve this, just like what I did before, I'm going to simply take 0.9 and divide it by 40.078, okay? And I get, and I'm not going to round my answer yet, and I'll explain why. I mean, I'm going to round to a certain degree, but I'm going to go out a number of decimal places, okay? So I'm going to stop here. So that's in moles now, okay? And then I'm going to do the same thing for chlorine. So 1.60 divided by its molar mass, and I get 0.04513. Okay? Remember, I didn't say that these subscripts represent the number of moles. I said it represents the mole ratio. And so what I need to do, I really want to compare how the number of moles of calcium compares with the number of moles of chlorine. And the way that I do that, because I want these to be whole numbers, all I have to do now after converting into moles is simply divide by my smallest number of moles. So I'm going to divide by 0.022456, both of them by that. So I need to get whole numbers for my subscripts, and I want a proper whole number ratio of the two. So when I divide 0.022456 by itself, I'm obviously going to get 1. And now when I plug in 0.04513 by 0.022456, I get 2.0097, which I can round to 2. Okay, so now I can write out my formula. It's Ca, the subscript is a 1, but I'm not going to write that because it's implied, Cl, subscript 2. And that is my empirical formula for calcium chloride. Now, one thing to note, if instead of getting a 2, let's say, for example, this is a totally separate problem. Let's say, for example, I got 1.5. Okay? How could I make 1 and 1.5 a whole number? Well, if I had 1.5, I could simply multiply both of them by 2. So then the calcium subscript would become 2. And the chlorine subscript would become 3. Obviously, this is a made-up problem. Okay? What if I have 1.33? right? I have 1 and I have 1.33. Well, I could multiply 1.33 by 3, right? Because 1.33 times 3 gives me 3.999, which gives me 4. And this would give me 3. So the only way you can round, like I did here, and say, oh, it's about 2, is as long as it's, for example, 2.0 something or 1.9 something. If you have a decimal like 1.5, I cannot look at that value and say, oh, it's practically 2. It has to be within the hundredths of being a whole number. Okay, so we'll see some more practice with this just to make sure it makes sense. All right, so for this problem, it's slightly different because instead of giving you grams, I give you percents of each element. Okay, so I tell you have 79.8% carbon and 20.2% hydrogen. Now the cool thing though is if I assume my sample has a mass of 100 grams, then 79.8% of that would give me 79.8 grams. And 20.2% of the 100 grams would give me 20.2 grams. Okay? So when you're given percents, you can just assume that your total sample size is 100 grams and just convert those percents, just change them into grams. Or you can say, oh, I have 1 gram of a substance, and so the mass would be 0.798 and 0.202, or you can decide whatever total mass you want. You'll ultimately get the same answer because we're going to be dividing at the end by the smallest number of moles, and so that'll correct it. I just think multiplying by 100 is the easiest because then you're literally just taking the percent and making it into grams. Okay, so remember, in order to get my subscripts, I need to first convert into moles. So I'm going to get grams on bottom for both of these, and I'm going to go into moles on top for both of them. Again, I need to put the molar mass of each of these. So I know that the molar mass of carbon is 12.011, and I know that the molar mass of hydrogen is 1.008. Okay, so now I'm going to take each of these masses and divide by their molar masses. So 79.8 divided by 12.011, and I get, and I'm not going to round too much because that'll mess up what I try and do in the end. Okay, so I've got that many moles for carbon. Then 20.2 divided by 1.008, I get 20.039, let's say 7 moles. Okay. In order to determine the ratio, I now need to divide by the smallest number of moles, which in this case is my 6.6439. Okay, so I'm going to divide both of them by that. Okay. Obviously, the one up top, this is just going to become 1. Now when I take 20.0397 and divide it by 6.6439, I get 3.016. So I am comfortable rounding that just to 3 because I've got 3.0 something. All right. Now to write the empirical formula, I've got 1 carbon, and then I have 3 hydrogens. So it's going to be CH3. And I'm done.